prove the derivative of sine x with respect to x is cosine x. I believe everybody learning calculus must have learned this. Now here I have a 7 method. I would like to present 7 methods to prove this derivative. Method 1, I think this method is most students learn from the calculus in their classroom. H goes to 0, sine x plus h minus sine x over h, right? Yeah, this then use the formula for sine. So this is sine x cosine h plus sine h and cosine x, right? Divided by h. Yeah, minus sine x. Sorry. Okay. Then these two common factors, sine x, you have a cosine h minus 1 plus leftover sine h cosine x, right? H. And this limit is a 0. You must have learned this limit. And this limit is 1. So end up with cosine x. Right? Okay, this is the proof that I think every students learn in their first course of calculus. Now, method two, I'm using this formula. Sine A minus sine B is equal to 2 cosine half A plus B and sine half A minus B. Okay, this is simply a formula in trigonometry. So we are using this formula, the limit h goes to 0, h sine x plus h plus, no, minus sine x, right? So we are using the formula. This becomes 2 cosine this angle plus this angle divided by 2. It's x plus half h. And this angle minus this angle divided by 2 is half h. Right? So this one equals to the limit h goes to 0. I can move this to over there because half h. This is cosine x plus x over 2 times sine h over 1. So this limit is equal to 1. When h goes to 0, this cosine, okay? So that is method 2. Now method 3, I'm using unicircle. This is a unicircle. The radius equal to 1. This angle, this is x. Then the arc length is x. This is x. If we increase a little by little, this is called delta x, then this arc length is delta x. Right? This height is sine x. This is x. This is 1. This is sine x. This is sine x. This is sine x plus delta x. This point, the y coordinate. So therefore, this length is let me use a big picture, okay? Move this picture over there. This one, this is a sine x, right? So this is x. This is delta x. So this is delta x. This picture is better. And this is sine. This height is a sine x plus delta x. This height. So this height is this. Therefore, this height is a sine x plus h minus sine x. This side. Well, this line segment is sine x plus h minus sine x. And this is a right angle. And this angle is formed by these two sides. This angle is formed by this and that side. This one is perpendicular to this. This line is perpendicular to this one when delta x approaches to 0, because this will be tangent. This will be tangent, right? When delta x goes to 0, this line is tangent to the circle. So this one is perpendicular to this one. This one is perpendicular to this one. Therefore, this angle must be equal to that angle. This angle perpendicular, this perpendicular to this line, this one perpendicular to this line when x approaches to 0. So therefore, this angle is this angle. This is the right angle. Therefore, these two triangles are similar. And this one is corresponding to this one, which is 1. This is a corresponding to this side, which is a cosine x. So in other words, this side, sine x plus delta x minus sine x, that is this side, over delta x, this hypotenuse, is equal to cosine x to the hypotenuse. Okay. This is true when delta x goes to 0. When this one goes to 0, it is true. Therefore, this one, when it goes to 0, that's the limit. Okay, that is the dx is equal to cosine. When this one goes to 0, this is the derivative of the sine with respect to x, and this equation will be true because this is perpendicular to this line. Well, it's anyhow. Yeah. I hope you follow. This is a very nice method. This is method 3. Method 4. I'm also using unit circle. Okay. This is unit circle. And there's a particle on it. This particle has a velocity, uniform velocity, which means every unit of time passing unit, 1 unit. Okay. This particle, the location is cosine x and the sine x, right? This is x. This is 1. So the vertical component is sine x. Okay. In other words, this point, the location is cosine x, sine x. Since the speed is a uniform speed, And the changing of the distance in y direction is d sine x over t, right? Yeah, this is the velocity of the particle in the vertical direction. Okay, and that is exactly equal to v multiplied by what? What this is x, right? The cosine x. So that is equal to v times cosine x. Since v is a 1, you see, uniform, therefore it's equal to cosine x. In other words, the speed of the particle in the vertical direction is cosine x. Well, that's a proof. It's physics. Well, it's nice proof. Now, method, how many methods now? 1, 2, 3. Now, method 4. This is method 4, right? I'm confused. This is method 3. This is method 1. This is method 2. Method 3, method 4. Yeah. Okay, method 5. Method 5. I let y be sine x, right? And x will be equal to x sine y, right? Then we differentiate both sides with respect to x. So this will be 1. This one will be 1 over 2 minus y squared, right? And the y derivative with respect to x. So y prime equal to this. Okay. So y prime is the dy dx, right? So dy dx is equal to this. 1 minus sine squared. That's cosine. Wow. So it's proved. Method 6. Okay, method 6, I'm using the Maclaurin series, right? Sine x is equal to x minus x cubed or 3 factorial plus x5, 5 factorial minus 7 plus 9 factorial. Right, and then take the d sine x dx. We take the derivative with respect to x. So this is 1. This is 2 factorial x squared minus x4 factorial. Okay, that is cosine. This is 7. Seventh proof, the complex number, right? Eix is equal to cosine x plus sine x. And you take both sides, both sides differentiate with respect to x. This is ix times x times I, right? So this means cosine derivative plus I sine x derivative, right? So the left-hand side is equal to then cosine x times I times I is a negative, and it's negative. Cosine x plus I sine x. So the real part must be same. Therefore, the cosine derivative is a negative sign. The sine derivative is equal to cosine. Okay, that sine is cosine. Wow, that's a, I don't know. It could be considered as a proof. But anyhow, overall, it's a 7 proofs.